All right, guys. Here's an example. This is all loaded onto Canvas, so I'm just walking through exactly what you see on Canvas. But it gives you a particle moving in a straight line, so its position is given, so it gives you a position function. It generally gives you time is greater than or equal to 0. It doesn't have to be greater than or equal to 0, but typically we do this like from the beginning movement of an object. So the first thing that you would generally have to do is find the velocity and acceleration functions. Velocity is the derivative of position, so you take the derivative of velocity. Acceleration over here is the derivative of velocity, so take the derivative of our answer for velocity, you get acceleration. Both of these we're going to want to set equal to 0 and solve, so solve by factoring. So here, velocity equals 0 when t is 2 or t is 4, which means the object will be at rest because its speed is 0 at 2 or 4 seconds. And over here, the acceleration equals 0 when t is 3. Now what we're going to do is we're going to create one of those sign line charts where we figure out when the first derivative is positive or negative and when the second derivative is positive or negative, but we're all going to do it on one chart. So I've got the completed chart down here, but basically I'm going to plug in velocity. My 0 for velocity is right there at 2. My 0 for velocity is right there at 4. And then I'm going to plug numbers in between here into velocity and figure out when velocity is positive or negative. So I plug in 1 and I'll get negative and positive. So if I plug in 1, I think I factored that wrong. That's not done correctly right there. All right, well, just like normal class, Mr. Gowdy making mistakes. So I plug in 1 and that would be negative, that would be negative, and so the two of them combined would give me positive. If I plug in 3, first one would be negative or positive, second one would be negative, multiply them together, I get negative in there. If I plug in 5 or 10 or 10 billion, velocity would be positive. So this means the object is moving to the right whenever velocity is positive, or it's moving forward, or it's moving up, depending on how you're thinking of this motion. When velocity is negative, it's moving to the left or back or down. When velocity is positive, it's again moving to the right. So we can write that up down here. The object moves to the right on the intervals 0, 2, and 4 to infinity because velocity is positive. The object moves to the left, etc. So you can see all that written down there. Okay. When is it at rest? That's a real common question. When is the object at rest? It's at rest at 2 or 4 because velocity equals 0. So we want to get in the habit of being able to write that sentence as well. But then we use acceleration. We put acceleration on the same graph. So you can see my acceleration marks are down here. Acceleration equaled 0 when t was 3. So I have a 0 there. So if I plug in 1 again, I will get I'll get negative. So from 0 all the way to 3, acceleration is negative, and from 3 onward, acceleration will be positive. So acceleration in and of itself is kind of worthless. What we care about is the combination of acceleration and velocity. So velocity is positive, acceleration is negative, which means the object is slowing down because they are opposite signs. Right in here, they're the same signs, so the object is speeding up. Right in here, they're different signs, so the object is slowing down. Right in here, they're the same signs, so it's speeding up, and it's going to speed up for all eternity. So eventually this thing is going to light speed or warp speed or ridiculous speed or whatever you want to do. So we write that sort of thing up as well in a sentence. The object is speeding up on the intervals. So 2, 3, 4 to infinity, because velocity and acceleration are the same sign. It's slowing down on those intervals because it's opposite signs. Okay? So all of that is stuff that you have to be able to talk about in some way. Now, taking those same concepts, they may ask you to describe the motion of the object at a specific moment in time. So if we were to freeze frame, what is the object doing? So really, they generally want 4 things in that description. Where is the object? That means what's its position. What direction is it going? That means we use velocity to determine, is it going forward or back, left or right, up or down? What's its speed? Since speed is the absolute value of velocity, we just take the number we got for velocity and we say, hey, there's our speed. Just make it positive. And then is it speeding up or slowing down? So we're going to compare velocity and acceleration functions to get that answer. So here, describe the motion of the object at 1 second. So I plugged in 1 to position, velocity, and acceleration. I just use those formulas from up here for position, velocity, and acceleration. The position was at 4/3. The velocity was +3. Acceleration was -4. So we write a sentence that has all 4 of those things in that sentence. So at t = 1 or at 1 second, the object is 4/3 feet to the right of the origin. It is moving to the right because velocity is positive. At 3, there's its speed, feet per second. And it is slowing down because velocity and acceleration are opposite signs. And if I want to, I can say how quickly it's slowing down. It's slowing down at a rate of 4 feet per second, which means it has fairly rapid acceleration at that point compared to other spots. So there's the entire sentence we would need to write. Okay. There are a couple other things, but generally this is the end of day 1. And we would practice from this point. So I'm going to stop here and we'll come back to the second half of this example problem, which is generally day 2.